Complete the following two-column proof. We are given that NO is parallel to QP and angle N is congruent to angle Q. So let's mark up our picture here for a moment and fill in our given in what we're trying to prove. So NO is parallel to QP, and we're also given that angle N is congruent to angle Q. So let's write that down in our given. NO is parallel to QP, and angle N is congruent to angle Q. That's our given. What we're trying to prove is NP is congruent to QO. So we're going to look here and see if we notice anything else. And the first thing that I happen to notice in this one is that in the top triangle we have OP, and in the bottom triangle we also have OP. So I'm going to mark that we have that. I'm going to say that OP is congruent to OP, and that is the reflexive property. Some other information that we have in this triangle, again, goes back to the parallel lines here, and it is two parallel lines. OP happens to be the transversal. So what we can say in this particular problem is that angle NOP is congruent to angle QPO because alternate interior angles are congruent. And let me mark that. NOP and QPO are congruent. And now what we have is we have two angles and a side from the top triangle. We have two angles and a side in the bottom triangle. So what we can say is we can say that triangle NOP is congruent to triangle QPO because of angle, side. And then we can finish with saying that NP is congruent to QO with corresponding parts of congruent triangles are congruent. That is abbreviated as CPCTC.